In this example, we need to solve the equation log to the base 7 of 3x minus 4 equals log to the base 7 of 6x minus 11. Well, what type of equation do we have here? It contains logarithms. And how many logarithmic terms are there in this equation? There's one on the left-hand side and one on the right-hand side. So there are 2 logarithmic terms. Now there are 2 basic type of logarithmic equations that have 2 or more logarithmic terms. The first is where every term is a logarithm. The second is where every term is not a logarithm. Which one do we have here? I only have 2 terms. They're both logarithms, so every term is a logarithm. And in that case, we solve them using the one-to-one property for logarithmic functions that says if log to the base b of x equals log to the base b of y, then x equals y. Looking at this equation carefully, it's important to note the base of the logs must be the same, and the coefficients of the log terms must be a 1. Do we have that in this case? Our base of the logs are both 7s, and I have a coefficient of 1 in front of each of my logs. So I can definitely use the one-to-one property. So since this statement is true, then I know the 2 arguments of the logs have to be equal. So I know 3x minus 4 has to equal 6x minus 11. So I've gone from a logarithmic equation to a simple linear equation. Let's solve that quickly. I'm going to subtract 6x from both sides of the equation. And I'm also at the same time going to add 4 to both sides of the equation. So I'm going to get 3x minus 6x is negative 3x equals negative 11 plus 4 is negative 7. Divide both sides by negative 3. And I get x equals a negative divided by a negative is a positive, so I get x equals positive 7/3. Even though we have a solution, we haven't quite finished. I started with a logarithmic equation, so I must check for extraneous solutions. So let's quickly check our answer. And in logarithmic equations, all you have to check is to make sure that the argument of each of the logs is a positive number. So I'm going to check 3x minus 4 to see if it's positive. Well, 3 times x is 7/3. So I'm going to turn 3 into a fraction by dividing it by 1. So that's 3 times x minus 4. Now my 3's reduce. I get 7 minus 4, which is positive 3. Is that positive? Yes, good. Now let's check our second argument, 6x minus 11. So I'm going to have 6 over 1 times my x value of 7/3 minus 11. 3 reduces with 6 twice. 2 times 7 is 14 minus 11 equals positive 3. That is also a positive number. So I have proved that both of the arguments of my logs are positive, so my answer is not extraneous. But as this was a simple problem, I have just proved that log to the base 7 of 3 equals log to the base 7 of 3. So I also know that this is a correct solution.